Hey, how y'all doing? I'm Will Wilder, the president of Wilder Systems. Wilder Systems is dedicated to building and integrating robotic systems to reduce the cost and defect rate in aerospace manufacturing. So that's me next to a robot that I integrated at Airbus in France. Put that project together to do fuselage body joints. You take one section of fuselage, take another section of fuselage, and you bolt them together. It's a lap shear joint. I've put together projects in I think 5 countries on 3 continents, and I've pitched projects at over 20 plants around the world. So I spent a lot of time in airplane factories trying to develop this solution. And then I'm starting my MBA at the University of Texas tomorrow. Okay, so aerospace drilling requires high levels of specialized labor, and there's a lot of ways to screw up a hole. So as far as the market goes, yeah, sorry, that's bad. Oh, wow. A lot of ways. All right, so anyways,
If you're going to do that, just quick get it out there real quick. Don't try to swallow it, okay?
There's a lot of ways to blow a hole, y'all. All right, so Boeing and Airbus have 12,000 airplane backlog right now, and I was reading the Financial Times a few minutes ago. Apparently, they're going to make 1,830 deliveries in 2020, which is a 45% increase over 2013. At the same time, in addition to Boeing and Airbus, there's a couple other suppliers that are going to compete with them in the single aisle market, which is their bread and butter. That's Comac, China, Bombardier, Canada, Quebec, and Sukhoi out of Russia. They all have products coming online right now. So, just a quick case study. So what you see here is an F-18 wing. There's about 700 holes per surface. To drill this, drill that structure, it takes about 230 minutes by hand, and it's literally done by hand with a pistol grip drill. So the guy goes up, puts up a strip template on each one of these ribs and spars to sight the holes. He'll drill it undersized, pilot drilling to location, full-size drill it, ream it, and countersink it. And there may be multiple full-size operations depending on the stack up. That's the material stack, so carbon, titanium, aluminum, whatever. So if you got a big hole, you got to drill it a bunch of times. So the solution, there's 3 possible solutions right now. So on the small side, if you don't want to use a pistol grip drill, you can use what's called an automatic drilling unit. It's a semi-manual tool. They cost about $8,000 each, but you still have a lot of tooling, which is application specific. That means like each rib has its own tool to sight the holes. The positive is it's a one-shot drill, so it'll drill, ream, countersink in one shot. You just push the go button and it goes. On the opposite end of the spectrum, you have monumental tooling. This thing runs on train tracks and costs $200 million. And it's like a 2-year lead time to get something like that in place, at least, depending on how long the business case takes to put together for the customer and so on. So in the middle, you have my solution, which is the lightweight movable gantry system. And so I'm going to explore that a little bit in more detail here. So right here, you've got the same wing jig. So this is the wing in a jig. And then right here, you've got a gantry robot, which can move left and right, up and down, in and out. And then it can normalize, which means it's got a couple degrees of angular freedom in order to make sure the hole is always perpendicular to the surface. So what the machine does, this gantry can move around the plant and is able to interface with multiple jigs in the plant. And once it comes up to the jig, it'll kinematically lock. That means it's repeatably positioned relative to the jig. And using RFID or other technologies, it's able to identify which jig it's on, automatically download from a server which part program to use. That's an NC program. And then it will go execute that program. So there's some IP associated with this. I filed a provisional patent on June 3rd. This isn't the most up-to-date version of the presentation, but on the real one, it says the patent number and so on. And then I'm working to finish up my IP strategy, which is to do a utility patent for the design of the machine and specific to the end effector, which is the business end of the robot that actually performs the normalization and drilling. And then there's a machine control software patent that I'm investigating and some enterprise software as well.
Are you writing these by yourself?
I wrote the provisional patent with the help of a law firm in Seattle. But yeah, that's dialed. Okay, so, but more questions maybe at the end. That's okay. All right, sweet. So basically, I'm looking at 4 ways to make money. Selling robots, that's a capital purchase. Maintenance contracts, which has both a one-time, which is a complement of spares, and then a recurring, which is like going out and changing the oil. Then there's the services side of things, where you provide like NC programming, process flow, these kinds of studies. And then finally, once I complete my IP portfolio, there will be licensing of patents and then recurring. I'll talk about it a little bit more offline, but how the patent licensing could work. And then there's software. So I'm proposing some enterprise software to distribute like key performance indicators relative to the process as the machine drills holes. It can keep track of cycle times and so on. Okay, so here's the roadmap of the company. I started this company last September. In June, I finished the system level provisional patent. Through this summer, I've been working on the end effector design and prototype and validation. So I should have that done this fall. In December, I missed the last deadline, but I'm pursuing an NSF SBIR grant. And then also, I forgot to mention this fall, like I said, I'm doing the MBA at UT, and I'm hoping to build out a team, get a couple more guys working on this with me. Then we're going to put together a bid for the Rice Business Plan competition, and hopefully win that. And then, anyways, do some patents, finish the patent portfolio next June to make sure that we keep the priority date from the provisional that I filed this June. Man, that's a lot. And then prototype and fabrication of next summer. I want to do a full-scale prototype and then be ready to present at the SAE Aerofast conference in the fall, which is the, it'll be in the United States this year. So this year, next year, sorry, this year it's in Germany. I don't have a prototype ready to present in Bremen, but I think next year it should be in Salt Lake City or something. And I'd like to have a full-scale prototype to present to the industry, and then do a white paper discussion and so on. Okay, so summarize the key benefits of this robot. It's faster, more repeatable, and will make less defects. Quick to procure, and then the idea of being able to interface with existing jigs on the factory floor makes it incredibly flexible and reduces the lead time compared to more traditional, like heavy integrated monumental robotic systems. Okay, so I've been doing the SEAL program this summer, and here's the patent number. So what I've done this summer is I filed the provisional finally, and then laid out an IP strategy. It's more with my lawyer than with y'all, but I validated my strategy with y'all. I've put together a product development strategy. Today we talked about it quite a bit. And then I've put together a second prototype of the end effector, trying to do a more design for manufacturing focused end effector. We can talk about it a little bit more later if y'all want to. And then let's see, I picked a software architecture which is based on the open system called ROS, Robot Operating System. And then I did some embedded software. I wrote a bunch of C. And then I did a little bit of market research as well. So his name is James Cumby, and he should be presenting his results to me this week. So that would be nice. See what he's been doing. So next steps for me, MBA, build out the team, and continue the prototype development. Hopefully I'll have a prototype, my second prototype this fall, which will be able to do a couple degrees of rotational freedom, and some auto normalization routines should be dialed. I'm going to finish the IP strategy by next June, and then through this fall and early spring, I'd like to raise enough money to put together a full-scale prototype next summer. And then at the same time, I'm in constant communication with contacts at Boeing and Airbus and Lockheed to try to find projects, and various suppliers as well, to try to find some projects to both do technical development for them and to get somebody to buy this robot so that we can prove that it works. Okay. It is. It's very important. You're absolutely right. So for Aerostructure Factory personnel who want to lower costs, increase throughput in their plants, while their systems offers a lightweight modular gantry. And I want to thank the guys guys at ATI to give me the opportunity to work in SEAL this summer. I had a great time. Very informative. All right.